All right, welcome back, Wildcats. We are going to be skipping lesson 3 for now. Don't worry, we will come back to it. But right now, I want you to go to lesson 4, ratio tables, and that is on page 39 of your book. All right, today we are going to be working on equivalent rates in the real world, how to write equivalent rates. All right, and we will learn what those are in just a minute. Right now, I want to look at this real world link. It says a punch recipe uses 1 container of soda, 3 containers of juice to make a batch of punch. I want you to draw red counters to show the number of containers of soda, yellow counters to show the number of juice, all right, to make 2 batches of punch. So for 1, it's going to take a container of soda and 3 of juice. So let's start with 1. Container of soda, 3 of juice. 3 juice. All right. If we want to make 2 batches, what are we going to do? We're going to just double it, okay? So I'm going to put another soda. My friend Marcy, she makes the best juice in the world. She puts like lemon lime soda in it with this sherbet ice cream and punch, and it is the bomb. All right. Now, how much soda and juice would we need if we double that recipe? We would need 2 sodas and 1, 2, 3, 4, 5, 6 juice. All right. This is something you're going to use a lot in the real world. When you get a family and you're doing Thanksgiving, you have to double, triple recipes, or Christmas, or any of those holidays. Or maybe you just get a whole family together. Maybe the in-laws are coming over and your parents are coming over and you're going to need to make a big meal. You're going to need to know this. All right. So this is how you double a recipe. Okay. All right. We're going to move down. Now it's saying draw red counters to show the number of containers of soda and yellow counters to show the number of containers of juice to make 3 batches. All right, so go back here. So we have 1 batch with this one, 2 batches with this one. So what are we going to need? If we want 3 batches, we got to have another soda. Then we've got juice, juice, juice for the first batch, juice, juice, juice for the second, and juice, juice, juice for the third. So now, how many sodas to how many juice do we have? We have 3 sodas, 9 juice, 3 to 9. All right, if it's asking you to double that, you probably will not want to reduce that because they actually want to see that ratio in full form. So if it's asking you to double or triple something, you don't need to simplify it because then it would take you right back down to the original answer. And they're actually, for these, they're looking for that higher number. All right, the last one says, find the ratio in simplest form of soda to juice needed for 3 batches. So if we simplify this, 3 over 9, if we simplify that, can we divide 3 into 9? Remember, always look at that numerator, see if it can go into the denominator. And it can. So we're going to divide by 3. And 3 goes into 3 once. And 3 goes into 9 3 times. So we have 1/3. What do you notice about that? It's asking you, what do you notice about that reduced fraction, that simplified ratio that you have right there? Well, if we look up here, our original ratio was 1 soda to 3 juice. And that's exactly what we have. You're back to your original ratio. So it's always a way to double check yourself. If you simplify it and you're back to that original ratio it gave you, then you know you're right. All right. If you need to pause, please do so now. I'm going to be moving on in 5, 4, 3, 2, 1. All right. So equivalent ratios. Equivalent ratios are quantities in the opening activity can be organized into a table, and that table is a ratio table. Because columns are filled with pairs of numbers, we have the same ratio. So basically what they're saying is each one of these doubles. They're equivalent because they all simplify back to this. So you will know if a ratio is equivalent if it simplifies back to the original ratio. We could take 2 6, and if we divide it by 2, we would be back to 1/3. 3 9ths, if we divide them both by 3, we'd be back to 1/3. So if it goes back to that original number, then you automatically know that it's equivalent. All right, here's an example. To make yellow icing, you need 6 drops of food coloring with 1 cup of white icing. So 6 drops of food coloring, 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of icing to get the same shade? So as you notice on the right, all they did was they took the yellow over the icing 6-1, and they knew that they wanted, over here, they knew they wanted 5 cups. So they went ahead and put that 5 in their table. Well, then they had to figure out how do we get from 1 to 5, and they decided, well, I multiplied 1 times 5 to get 5. What you do on the bottom, you have to do on the top. 6 times 5 is 30. So the biggest thing, remember, what you do on the bottom, you do on the top. So if you can figure out how you got to 1, you can do the same on the top, and it's going to be correct. Okay? Now, you don't want to add, though. You can multiply, divide, but you do not want to add on these. All right, in a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. Okay, that would make me want to barf, I'm just saying. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. So they took the original ratio, 66 over 12. 66 hot dogs, 12 minutes. And they wanted to divide it down to figure out how many he ate in 2 minutes. So they divided by 2. Because both of those numbers are divisible by 2, because they end in even numbers, we knew we could divide by 2. So they divided by 2 and got 33 over 6. Then they divided it by 3, because you can't divide by 2. And they got 11 over 2. Now notice, these are not the same, and that's okay. Because again, as long as you multiply by the same thing, it's going to be equivalent. Sometimes you might have to go down and then multiply back up. Or multiply up and then divide back down. Because if you can't get down to 2 minutes, and then you might have to go up or down to be able to get to that 2 minutes. Some of these can be a little bit tricky. So again, they divided down by 2, and then they divided again by 3. And as long as they do the same on the top and the bottom, it's okay. All right. I don't know why that keeps coming up on me, but it's not very nice. All right. Let's try these got it problems. A patient receives 1 liter of IV fluids every 8 hours. So the first thing they did was they gave you the 1 to 8. 1 liter of fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? So we know how many fluids we need, how many liters. We had 1. They want us to get to 4. How will we get there? 1 times 4 will give us 4. What we do on the top, you've got to do on the bottom. So 8 times 4, 32. Try the next one on your own. It's going to be a little tougher. I want you to try it on your own. Pause this video. I'm going to go over it in 5, 4, 3, 2, and 1. All right, to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. They gave that to us right here. Find the amount of sugar needed for 4 cups of strawberries. So I need to get from 16 to 4. Well, what if I divide, both these look like they could divide by 2. Let's see, if we divide by 2 on the top and the bottom, we would get 6 over 8. Now, how could I get from 8 to 4? I could divide by 2 again. What do I do on the top? or bottom, I got to do on the top. 6 divided by 2 is 3. So for the amount of sugar needed for 4 cups of strawberries, I would need 3 cups of sugar. That is a lot. Yikes. I didn't know jam had so much sugar in it. So again, all I did was I found something I could divide by both, and I found a 2. I got 6/8, and I knew I could divide this by 2 again to get 4. So what I did on the bottom, I had to do on the top. All right, if you have any questions, please feel free to let me know. I will be around to help you. I'm going to do the guided practice in the next video. Have a great day and hang in there. I'll be right back.